Good morning, students. This is Professor Rupak Lonare from Nagpur Institute of Technology. We will study today the third unit of electrical machine 1, that is the DC machine. So, with the screen, and you can just see the slides based on the unit number 3. The unit 3, that is the DC machine. So, as you know that the name suggests you DC machine is nothing but the supply will be a DC one. So as there is availability of AC supply maximum times, we have to convert into DC one by means of rectifier, and then we can use supply as a DC for running the DC machine. Now moving to the next part, that is the parts of the DC machine. So we can say that there is a robust construction of this particular DC machine. So outermost part is nothing but called as a yoke. Then there are two brush lines, brush axis there, and nothing but you can see these are the brushes. Okay, this one is a field winding. The poles are there, field poles, south poles and north pole. So associated with this, the field winding will be there. These are the field winding showing minus, or you can say the dot and then plus. So plus indicates that the field, that is the line of fluxes, are inserting inside the screen, or you can say the blackboard. And then this dot, you can say that it is nothing but outward to the screen, means coming towards the listener, or you can say observer. Then field poles are there, main field axis and brush axis. Main field axis is a vertical axis and brush axis is a horizontal axis. Armature conductor. The armature parts will be there, and in that armature, the conductors will be placed. So outermost part is yoke. Then there are the poles, that is called as the field poles, which are useful to create the magnetic field. And then nothing but innermost part, that is nothing but you can say the armature. So armature having armature conductor, and these poles are nothing but surrounded by the field winding. Move to the next part. This DC machine can be categorized into two parts. First one is DC generator. So it will produce a DC EMF. Now already the generator is producing a alternating EMF, but with the help of some commutator here, it will be generate the DC. So that's why it is called as a DC generator. Now, as you know that in DC generator, according to the Faraday's law of electromagnetic induction, okay, so whenever the current carrying conductor is moving in the steady magnetic field, then EMF will get produced. So this one is a current carrying conductor. By means of mechanical force, it is moving inside the stationary field. This one is a stationary field. So you can get a EMF produced at the outermost part, and this EMF will be getting to the electrical load. Okay. Next part is your DC motor. So in DC motor, you can see the DC supply will be there, and you will get the mechanical force at the output. This electric field will be there, this magnetic field will be there, and you will get output as a mechanical force. So by means of left hand rule, if three fingers are stretched in such a way that this outermost finger, that is nothing but you can say thumb, then fourth finger and the middle finger will be stretched in such a way that it will be perpendicular to each other, then this gives a thumb will represent the motion, the fourth finger will represent the magnetic field, and then this finger is represent the current. So you will get the direction of these particular things. Okay, so next part we will see in next portion. Thank you very much.